Yes. So today we are going to focus on percentage yield of chemical preparation. We are given that 30 grams of C3H8, which is propane, was burnt in excess air to produce 70 grams of CO2, and we are asked to calculate for the theoretical yield and the percentage yield of CO2. This information is given in square bracket. The molar mass for C3H8 is 44, and that of CO2 is 44 grams per mole. So now let's start. Since this is a combustion reaction, we will write a combustion reaction equation for this one. So C3H8, which is propane, plus O2, moving into, for every combustion reaction, we all know that CO2 and water vapor will be produced. So now, we have to balance this equation. All what we need to do is, first of all, consider this one. Hydrogen is 8 over here. Hydrogen is 2. And so I can choose to put 4 in front of this one. So 4 to making 8. So we are okay with hydrogen. 4 times this oxygen. We are having what? 4 oxygen over here. And plus this one making 6. And so I can choose to put 3 in front of this one. So that's C3. And since 3 times 2, 6 plus 4 is 10. Oxygen is 10 over here. So I can choose to put 5 in front of this. So now the equation is balanced. Now, we first of all find for the number of moles of C3H8 that reacted with CO2. So now, you know that number of moles is equal to mass over the molar mass. So the number of moles for C3H8 is equal to, the mass of C3H8 given was 30. So 30 out of the molar mass, which is 44. So dividing this, you'll be having 15 out of 22 moles. So this becomes the number of moles of C3H8 that reacted with CO2. Now from here, using mole ratios, I can say if 1 mole of C3H8 reacted with 3 moles of CO2, then I can say 15 over 22 moles of C3H8 reacted to, we don't know the amount that reacted. So now, using cross multiplication, this one will multiply here, this one will multiply here. So I can represent this one by, let's say, X moles. So equating these ones, you produce X multiplying this, so X is therefore equal to 15 out of 22 times 3. So now, X is therefore equal to 15 times 3. We are having 45. So 45 out of 22 moles. So this becomes the number of moles of CO2 that is produced. Now, we have to calculate for the theoretical yield first of all. So in calculating for the theoretical yield, you know that this same number of moles is equal to mass over the molar mass. So now, the number of moles for CO2 is equal to 45 out of 22. So substituting this one into the equation, we're having 45 out of 22 is equal to, we are finding for the theoretical yield, so M out of the molar mass for CO2 is 44. So by this we can cross multiply, so 22 times M is equal to 45 times 44. Dividing both sides by 22. So M will therefore be equal to, this one cancels here, 2 times 45 times 2, we're having 90 grams. So this becomes the answer for the theoretical yield. So initially, the actual yield for CO2 was 70 grams, but for the theoretical yield we're having 90 grams. And the final part says we should calculate for the percentage yield of this chemical preparation. So from our formula, percentage yield is equal to the actual yield divided by the theoretical yield. So the percentage yield is therefore equal to the actual yield of CO2 was 70. So 70 out of the theoretical yield, which is 90. So this cancels this. We're having 7 out of 9. But always note, this one is in percentage, so whatever you get here, you multiply by 100. So 7 out of 9, we'll be having something like 0.11 times 7. So we're having 0.77. This whole expression times 100%. We'll be having 77 point, let's say, 7. So because this one is 0.111. So this becomes the percentage yield of the chemical preparation.